Hello and welcome to the GATE Electrical Engineering Previous Year Question Solutions. Myself, Jitendra Kumar. I am PMRF Research Scholar at IIT Bombay, and today we will see one very interesting question based on three-phase transformer efficiency calculation, which was appeared in GATE 2018, and here they have asked to calculate full load efficiency of the transformer operated at unity power factor. And this is three phase, so we don't need to worry here if we know the basics of three phase, or if we don't know, we will see what we can do here. So in three phase, first we will see the connection is delta and star. This is root 3, guys. Sorry for the mistake. This is root 3, and these are connected in delta and star fashion. So I will also draw one delta connected transformer. Pardon me for my bad drawing. And here one phase, two phase, three phase. And here it is 3 kV line to line voltage connected with a star in secondary. And here line to line voltage is root 3 kV. Now we have to calculate efficiency. For efficiency, what are the parameters we will be required? So to calculate efficiency, we need the percentage of loading, that is X, how much loading, since it is full load, so we will use X as a 1 into kVA rating of the transformer into power factor of the transformer. The same thing will come to the first term of denominator, that is X kVA cos phi plus iron loss plus X square copper loss. If you can recall this formula, then it is very good. Otherwise, you should go back and revise this. So now we have the loading, that is X is equal to 1. We know that. We know that kVA, that is 900 kVA, is also given. Now power factor, it is also given. I think everything is given. Now iron loss, it is also given. Again 10 kilowatt. Copper loss. Now we don't know copper loss, and that is the question. It is asking indirectly how to calculate copper loss in three-phase transformer. That's it. So how to calculate copper loss? Now we will see that resistance is given, and if you can remember, or if you can recall the concept from per unit, the copper loss is nothing but the per unit value of resistance, and that is equivalent resistance. Either it would be referred to the primary side or to the secondary side, doesn't matter. Whichever side you want to refer, you refer. Now we need to calculate the per unit value of resistance. For per unit, we need to define base value. Uh, since you know per unit value is the actual value of the parameter divided by base value of the parameter. Actual value is given, base value we can decide. So we will take the base value of voltage. I think we should go with a star, since a star is very common. So we should refer to the secondary. So base value we will take on the secondary side, that would be root 3 kV line to line. And kVA rating of base is 900 kVA. Now we need to calculate Z base. Let me change the color here so that we won't be confused. So Z base would be voltage ka square line to line divided by kVA. Here you can also do it by uh, seeing the units. So here V by I would be the equivalent unit. So now root 3 into 10 raised to power 3 square divided by 900 into 10 raised to power 3 volt ampere. So it would give you nothing but the, if you calculate it on your calculator, it would be 10 by 3 ohm. So we have calculated Z base on the on this side. In power system, you may study that how to transfer Z base. We just have to apply the turns ratio. That's it. But we are not going to do that in this question, and we should focus on only one side. Now, to calculate RPU, we need R2PU plus R1 dash PU. R2PU, R1PU would be this side, and if we refer to this side, that would be R1 dash PU. Okay, so let me move on. I know that we have R2, that is nothing but 0.02 ohm. This value I am referring to 0.02 ohm. So R2PU would be 0.02 divided by the base value. Base value was nothing but the 10 by 3. So here we will take 10 by 3, and that would come out to be 0.006 per unit. We are done with R2 per unit. Okay. Now we will see R1 dash per unit. For that, we will calculate R1 dash first, and R1 dash would be nothing but the R1, and R1 is 0.3 ohm. So here it is 0.3 into V V2 phase divided by V1 phase, that is nothing but the turns ratio. So V2 phase voltage is root 3 kV, the line value. So root 3 kV, and since it was connected in a star, secondary was connected in a star, so to calculate in phase voltage we have to divide it by root 3, so it would be 1 kV V2 phase. How much would be V1 phase? It was connected in delta, so line value and phase value would be the same, so it would be the 3 kV. Now we will put both the values in this equation, we will get R1 dash. So R1 dash would be 0.3 into V2 phase 1 divided by 3 square, and so here R1 dash would be 0.3 divided by 9, so 1 by 30. And if we do further, I am converting it in per unit, so 1 by 30 divided by 10 by 3 ohm, this is in ohm, so we will get 0.01 per unit. So this we have calculated R1 dash per unit. This we had calculated R2 per unit. So now we have all the values. So copper loss would be nothing but R1 dash per unit plus R2 per unit, and that is nothing but 0.016 per unit. Now we have calculated copper loss also, so we will plug in all the values in the formula of efficiency and we will get the value of efficiency. So percentage efficiency would be X was 1, kVA was 1, cos phi was 1 divided by 1 plus Pi. Pi was 10 kilowatt. We also have to take it in terms of per unit. Pi per unit would be 10 divided by 900 kVA. So 1 by 90. Here Pi would be 1 by 90 plus copper loss would be 0.00016 pu. 0.16. Now, if you calculate it, then we will get 97.36 percentage. So this is the answer for the question 97.36 percentage and it was asked in GATE 2018 and it is very important question. We should solve more questions on this topic or this formula based on three phase. You should be good at basics of a star and delta, then it would be fine. Thank you very much.